and welcome back to Teacher Gimbel's channel. Today we're going to be going over Illustrative Math, Algebra 1, Unit 1, Lesson 7 practice questions. If you have any questions, please leave them in the comments below. And if you like this video, please make sure to like and subscribe so you can see more videos like it. Let's get started. Problem 1. Write a formula you could type into a spreadsheet to compute the value of each expression. We have here 19.2 times 73. So to compute this value, I would type in an equals number. I would type in my first number. We don't have a multiplication sign on the keyboard, so I would type in a little asterisk, and that represents my multiplication times 73. And we're done. For number 2, we type in an equal sign. We're going to type in our number. We don't have an exponent button, so instead we use this little button, which is the caret button, which represents raised to the 5th power because it is a 5. For this one, 2.34, we don't have a division sign, so we're just going to use a slash like that to represent divided by 5. We do the same thing for fractions. So in this case, we do 91. We use the divided sign, divided by 7. And we're done. That's it. Let's move on to problem number 2. A long-distance runner jogs at a constant speed of 7 miles per hour for 45 minutes. Which spreadsheet formula would give the distance she traveled? Well, I first noticed that here we have hours and here we have minutes. So we're going to have to convert one to the other. I see in our answers, we start with a 7. So I'm not going to touch the 7 miles per hour. I'm going to say, how many minutes is 45 minutes of an hour? So we're going to say 45 minutes, and we're going to put it over 60 minutes of an hour. The minutes will cross out. We can divide the top by 15 and the bottom by 15 to simplify this fraction, which will get us 3 over 4. So the real question is, we could rewrite it as 7 miles per hour for 3/4 of an hour. So we're going to cross this out. We're going to cross this guy out over here. And then we're going to look at our two answers. And if it's 7 miles per hour for 45 minutes, we're going to multiply it here. And if we notice, we have an asterisk, just like we used up here, to represent multiplication while using a spreadsheet. And we're done. Let's move on to the next question. I like these quick questions. In a right triangle, the length of the sides that makes a right angle are 3.4 meters, 5.6 meters. Select all the spreadsheet formulas that would give the area of a triangle. Now, with triangles, I always draw a picture. We have a right triangle. One side is 3.4 meters. The other side is 5.6 meters. These are the two sides that make a right angle, so I know it's not the hypotenuse. We want the spreadsheet formulas that would give the area of this triangle. Well, first I have to know that area is 1/2 base times height. So in this case, area would be 1/2 5.6 times 3.4. And I know that these two values are interchangeable. So right away, I see this can't be an option because it's missing the 1/2. I look over here and I see no 1/2 here. We're multiplied by a 2, so I know this is wrong as well. So let's look at these three options. This one, using the commutative property of multiplication, which just means that the order of the numbers could be mixed up, matches our answers exactly, which is perfect. Now this one over here and this one look very similar, but let's look at the difference. This one has parentheses and this one does not. So what the parentheses mean is this guy is the two values multiplied, and again the asterisk multiplication divided by 2, versus this one over here is going to be this value times just the second one divided by 2. So this, when we have the 1/2, we're multiplying it both by the 5.6 and the 3.4. So this over here would not be correct, whereas this one is divided by both of them. And so this would be your correct answer. If you're having some trouble with this question, it means you should go back and review your order of operations and some of your fractions from earlier lessons. Let's keep going. Problem number 4. The spreadsheet should compute the total ounces of sparkling grape juice based on the number of batches, ounces of grape juice in a single batch, and ounces of sparkling water in a single batch. So the number of batches is 4. The ounces of grape juice in one batch is 3. The ounces of sparkling water in one batch is 7. So the total ounces should be. So write a formula for cell B4 that uses the values in cell B1, B2, and B3 to compute the total ounces of sparkling grape juice. So let's think. To create 1 ounce of sparkling grape juice, we're going to need 3 ounces of water, so 1 OZ of grape juice is going to be 3 ounces of sparkling water, 3 ounces of grape juice, plus 7 ounces of water, which is going to equal 10 ounces. In this case, we have 4 batches, so it's going to be 4 times 10, which gives us 40, which is going to equal our final batch number. So let's think about what we did. For our formulas, we always start with our equal sign. So it's going to equal, now we're going to multiply the value of B1, because B1 is how many batches we have, times what it cost, the number of ounces in B2 and B3, what we added. So times B2 plus B3. And that gives us a formula, which will compute the total number of ounces sparkling grape juice that you will make. How would the output in the formula change if the value of B1 was changed to 10? Well, if we had 10 number of batches instead of 4, we would end up with 100 ounces instead of 40, because we have 10 ounces per batch. Here we had 4 batches. Here we have 10 batches. What would change about the sparkling grape juice if the value in B3 was changed to 10? So if this was 10, the amount of ounces it would take instead of 3 plus 7 would be 3 plus 10. You need 13 ounces per batch. The 4 would stay the same, which means we'd have 4 times 13, which would give us 52 total ounces. So the values would change. I don't think there's an E in ounces. The value would change differently if we change a value in B3 compared to the value in B1. What's most important is to situate yourself with these values so you know what they mean, so you can understand what you're doing when you're changing those numbers. If you have any questions, please pause the video here, and you can rewatch this as I move on to the next section. Start it again when you are ready. Problem number 5 and 6. The dot plot below represents the same distribution of data. So we have a dot plot here and a box plot here. How does the median change when the highest value is removed? How does the IQR change when the highest value is removed? So let's think about what's happening here. When the highest value, 5.2, is going to be removed, the median, which in this case we know is 3.5, so our median is 3.5 right here. The chance that the median changes is not that much, because the median is one of these numbers in the middle. And we could count it out, but it looks like there's about the same at the same time. So I would say stays the same, because we have 2, 4, 5, 6, 7, 8, 9 values here, 2, 4, 6, 7, 8, 9 values there. So when you average those middle two, it's going to stay at 3.5, and the median will stay the same. Now the IQR, so when your IQR is moved, at this point in time, our IQR is going to be, well, we cross out this one, we cross out this one. I'm really checking to see what's happening on this side over here. So it's going to be 4.2 on this side, and it's going to be 3.1 on that side. In this case, the IQR, I don't think it changes either. It's because this value is going to stay the same, and the IQR isn't going to have any change. So it stays the same as well. All right. If you think I'm wrong, definitely do the calculations yourself and post in the comments and let me know what your answer is. Describe the shape of the distribution shown in the histogram, which displays the light output in lumens of various light sources. So as I said before, when I'm looking at distributions, I always see if there's a tail or not. It looks like there's a tiny little tail, so I'll say it is slightly skewed to the right. Why is it on the right? Because the tail is on the right. And that's what I would say there. It's not a very strong tail, which is why I just wrote that it was slightly skewed. If you have any questions, pause the video here as I move on to the last problem. The dot plot represents the distribution of the number of goals scored by a soccer team in 10 games. So we've got all these different numbers. The 3 games, they scored 0. 1 game, they scored 4 points. In 4 games, they scored 1 point, and in 2 games, they scored 2 points. If possible, find the mean. If not possible, explain why not. Well, we can find the mean here because we're just going to add up all of the values. I have 4 ones because there's 4 dots. I have 2 dots on 2, 1 dot on 4, which gives me 4, 5, 6, 7, 8, 9, 10, 11, 12, which is 12 over 10 games, which gets me 6 over 5. So our mean is going to be 6 over 5. The median is the middle value, which we can also compute the same way we've been doing it. And over here, we see that the mean is going to end up right smack in the middle over there, and that's going to be 1. So the mean is slightly higher than the median. Did the soccer team ever score exactly 3 goals in one of the game? Nope. There are no dots in the 3 value, so they never scored exactly 3 scores in one of the games. In a histogram or a box plot, you wouldn't be able to see that, but because we're looking at a dot plot, we know that sometimes they scored 0, sometimes 1, sometimes 2, and sometimes 4, but they never actually scored those 3. If you have any questions, please put them in the comments below. If you like this video, please like and subscribe, and I will see you on the next one.